Good evening, everyone. So, let us continue our session for CCNA. In our past few classes, whatever we have discussed is what is CCNA, what is the use of it, what role we can play in the IT Health Support Center, and all that. And in our today's session, we are going to see further things like how routing will take place, and before that, what is routing actually. Fine. So answer to this question is routing is nothing but the sending the packet from one network to another network. Routing is nothing but the sending packet from one network to another network. This involves two things. First one, while sending the packet to the different network, how to identify the other network exactly. This is the first part. And after that, what is the most reliable path, secure path to send that data packet to that destination network. These both tasks is going to be performed by the device called router, R-O-U-T-E-R. Router is responsible for routing. Okay. Now, while configuring the router, let me open the software. We can configure the router in two manners. First one is going to be hardware router and second one is going to be software router. So most of the people will prefer the hardware router. This is what I have opened Cisco packet tracer for the practice purpose, and this is what routers somewhat look like. It's having serial interfaces by name slot 0 and slot 1 called as WAN interfaces, and the other two interfaces are fast Ethernet interface. You can use gigabit Ethernet also, and we'll be having one console port for the initial configuration of the router and one auxiliary port for remote access purpose. Fine. So after that, let me delete this one and open a file which I have already configured. That means did my homework. So this is the file on which we are going to check it out. How packet can transfer, how packet will get transferred from different networks to other networks, destination networks. So as you can see in this file, here I am having three routers. One is located in Hyderabad, another one is in Bangalore, and the next one is in Chennai. Now, the thing what I have done in this file is this devices which are connected in the Hyderabad network, that I am using 10th network of class A. You can see I have given the IP address as 10.0.0.2 and followed by the same thing 10.0.0.3, like that. I have assigned the IP address to the devices which are present under this router. And when it comes to the fast Ethernet interface, the IP address what I have configured is 10.0.0.1, which is going to be the default gateway. This is going to be the default gateway for all the devices. No matter how many devices you are having, the gateway should be the same thing. And the serial interface, serial 0 I have configured. The serial 0 interface I have configured this slot. Serial 0 I have configured as 192.168.0.1, and I have not configured anything as serial 1 interface. When it comes to the middle one, the Bangalore, the router which is present in the Bangalore, here the network what I am using is class A20 network. Because of that, I have configured the fast Ethernet interface of the router, nothing but FE0/0 as 20.0.0.1. Of course, it's going to be the gateway for all the devices which are present under that network, and the same class network ID and different host ID I have assigned to the devices present under this network. And this Bangalore router both interfaces I am making use. As you can see, I am using the serial interface 1 as well as serial interface 0. The serial interface 1 I have already configured as 192.168.0.2, and the serial interface 0 I have configured with 172.16.0.1. When it comes to Chennai router, the network what I am using is 38th network, and the IP address is 30.0.0.2, and the default gateway is 0.1. And at this last router I have configured only serial interface 1. Fine. Now if it is somewhat confusing what IP address I am using and why I am using these IP address only, means let's check it out, this information under rules of routing. Just now we understood what is routing, sending the packet from one network to another network. That router, that routing process is having some rules. The first rule is head office LAN. That means that all the devices should be as the same of head office fast Ethernet interface. This is the first rule. The devices what you are using, this is called LAN interfaces. So the devices what you are using, that should be in the same network as your router LAN fast Ethernet interface. That's why I have given this. And the second rule is, on the branch office side, same thing should be done. Means whatever devices are present in the another network, they should be in the same network ID as your fast Ethernet interface of your router. And the third and last rule is WAN interfaces should be in the same network. WAN interfaces, the interfaces what you are connecting via WAN, those interfaces should be connected in the same network. That's why we have used, by following these rules of routing, I have prepared these files. After that, once you have configured all the interfaces correctly, automatically in all the routers one table will get created by name routing table. Now that table has to get filled up with the destination networks, with the valid destination network, so that whenever required the packet can be sent from that network to another network. How we are going to fill up this table? By default the table will be empty in a brand new router. Now our job is to fill up the table with the valid routes of other destination networks. This can be done in few methods. The first method is called as static routing or manual routing. Let's see what is this first. After that we'll go for the another method. The static routing means the manual configuration. We admin has to fill up the table manually. Admin has to fill up the table manually. That means router will follow only administrator instructions. It can send the packets to only those destination network which has been manually added into the routing table of the router by the administrator. This type of routing is called as static routing. We can prefer the static routing in few scenarios when the topology is small, when you are having small number of networks which wants to communicate with each other. Means example, you can say head office and branch office. The requirement of branch office is only to communicate with the head office with no other network. That's it. If this is the case, then you can go for the static routing. The other situation when your topology is big and when there is a requirement of communicating with more than 5 to 6 or multiple different networks in the office hours, then static routing is not preferable. Why so means the first disadvantage of the static routing is somewhat difficult to configure. The syntax is going to be somewhat difficult to configure. The second disadvantage is router follow only administrator instruction. Means if any changes occurs in the topology or in the network, those changes router will not get it automatically. Again, administrator has to sit and it has to update the router manually. The only advantage, according to me, what I can say regarding static routing is administrative distance. Administrative distance, called as AD, is 0 for static route. Remember, the less the administrative distance, the more reliable the route will be. You will come to know what is administrative distance more clearly in our next coming classes. So just for that sake of time, remember static route administrative distance is 0. After that, the other type of routing what we can do is dynamic routing. Dynamic routing. One second, let me give the heading to this one also. Static routing. And here dynamic routing. Dynamic routing is preferable. Why it is preferable means router itself will take the data packet forwarding decisions on its own. Just what administrator has to do is administrator can configure any one of the dynamic routing protocol. We are having so many depending upon the distance, depending upon the terminology. We are having RIP, routing information protocol. We are having OSPF as a protocol, open shortest path first, and we are having EIGRP, enhanced integer gateway routing protocol. Like that, we'll be having so many different dynamic routing protocol. Anyone, depending upon the network requirement, anyone administrator has to configure. Rest of the thing, the router itself will take the decisions. How it will take the decisions? In dynamic routing protocol, what will happen means each and every router will broadcast the information. That information is going to be in the form of an update packet. Example, if you talk about the Hyderabad router, which is here. Now, the moment dynamic routing protocol configured, the Hyderabad router will broadcast one packet in the form of update. That update packet will contains the direct connected network information. The default broadcast address is going to be 255.255.255.255. Of course, in few cases, it can be multicast also instead of broadcast. That is a different story. Now, the moment it broadcasts, that packet will be going to the Bangalore router as well as to the Chennai router. After getting that information, they'll store in the routing table. Same thing is going to be done by the Bangalore router and Chennai router. What I'm trying to say is, once we have configured the dynamic routing protocols, all the routers will start broadcasting their direct connected network information in the form of an update packet. If they started like this, then all the routers will be getting all the network information automatically and they'll be storing in their routing table for further usage. It's not necessary that once we got the data packet means definitely then and there itself we have to revert it back. Acknowledgement is not required over here, but they'll keep it in the routing table for further usage. This is how dynamic routing works. Depending upon the protocol, again administrative distance is going to be different. Like when you talk about the dynamic routing protocol, RIP, routing information protocol, and it is also having the second version by name RIP version 2. Then it is having OSPF, open shortest path first. Then it is having EIGRP, enhanced integer gateway routing protocol. Each and every dynamic routing protocol will have its own specifications. Depending upon your requirement, we have to select any one of the dynamic routing protocol and we have to configure the router. Dynamic configuration will be somewhat easy while compared to static routing. Okay, fine. So these are the few types of routing what we have to check in our upcoming classes. Now, first thing, let me go to the Hyderabad router and I am accessing the router. This router from the console cable, as you can see, which is already connected. I have gone to that system and I have opened terminal, accept the default settings and click OK. Now, this is the first mode of a router called as user mode. From here, I am going to enable mode. Then from here, I am going to global configuration mode. Like that, I can type the commands, I can proceed further. If you want at any point of extent, if you want to go back, simply type exit and hit enter. You'll be back. This is the privilege mode. Again, exit, you'll be going completely back. Like that, these are the starting three modes of a router. Here in this first mode of the router, we'll be having user mode, then we'll be having enable mode, then we'll be having global configuration mode. User mode is represented as below and enable mode is going to be represented by router hash symbol and global configuration mode is going to be represented like this. The first thing, user mode, we got nothing to do with it. It's like a first step. Here very less number of commands will work, means like ping. If you want to check the connectivity, ping command, or very less few commands, show my version and all those things. The second mode is somewhat important to us. Here all the viewing commands will work. In enable mode, also called as privileged mode, all the show commands and verification commands will work. Means you want to check the status of a router. Here also you can go for ping command, or you can go for viewing the routing table, or you can check it out any one of the interface in brief. And the third global configuration mode is, here in this mode you can go for configuring your router. You can go for configuring of your router. Configuration, complete configuration part is going to be happen in global configuration mode. So by default it will be it's getting open in user mode. From this, if you want to go to privilege mode, simply type enable or en will be sufficient. And if you want to go for the global configuration mode, then this is the syntax what you have to type. At a given point of extent, type exit and hit enter. You'll be going back. Now I want to see the version of the router. This is a command, show version. Here you'll be getting almost all the information by single command only, but where we have to concentrate on this is on the version. This is the Cisco ISO software, 1841 software, and this is the information. Version 12.3 software I am using. Like that, I can check my version. Then if you want to see the routing table, the syntax will be show IP route. Here already it is statically configured. Understanding this table is somewhat important. C is nothing but the direct connected interface. S means it's statically connected. And when you configure rest of the dynamic routing protocol, for verification it's going to be R, which stands for RIP, and B, which stands for BGP, and O stands for OSPF. Like that, the moment you configured and verify one by one all the dynamic routing protocol, you will be getting these type of things. Let me go to another router and open the terminal. Show IP route. Here also I am getting some information. This command is very important to view the routing table. It's showing that serial, static routing and direct connected interface. 10.0.0.0/8. 8 is nothing but the default subnet mask, network bits, number of network bits. It is statically connected via serial interface 0 by 1 by 0, and direct connected interfaces are 20.0.0.8, as you can see. And one more static is 30.0.0.8. Like that, you can configure the router and you can see. Check. Here also it's statically configured. Now let me close all this stuff and let me go to any system, any network. I'm going to Hyderabad and I'm opening command prompt. Let's check the connectivity. Because it's already configured statically, let us check the connectivity. Now I'm using the ping command. Ping space the other network device IP address. So here I am going to give 20.0.0.3. I am on Hyderabad network device and I am checking the connectivity with the device which is present in Bangalore. 20.0.0.3. Yep. As you can see, first time I got the request timeout and second time onwards I am getting the reply. Why first time we got request timeout? This is also somewhat important thing what we have to keep in mind. After configuring, when you try to check the connectivity with another device, ARP will start working, which stands for Address Resolution Protocol. Means the moment switch got the packet, it will check the destination address. What is the destination address? So if switch is having the destination address in its table, MAC address table, then directly it will forward that packet to the destination device. If not, then again ARP will work. While by the time it completes, it will take some time. So because of that, we are getting first time as a request timeout. Thank you so much. This is what I was trying to show you in this session. Fine. So
it was very much clear, sir. Can you just repeat the last 2 points what you were saying?
regarding static or dynamic?
Yes, please.
Okay.
Regarding dynamic.
Regarding dynamic means in dynamic there will be so many protocols, different protocols what we are going to have. Means our main intention in both static as well as in dynamic, our intention is to fill up the routing table. Our intention is just to fill up the routing table. So while configuring the router dynamically, our burden, administrative burden, is getting reduced a lot. Means just
Okay.
what is our job is just to configure one of the dynamic routing protocol. It's going to be so many numbers. As I said, it can be RIP, routing information protocol,
Okay.
or it can be OSPF, or it can be EIGRP,
Oh,
which suits your network. Every network will
yes.
have its own requirement and needs, of
Okay.
course. Depending upon that, which protocol suits your requirement, we have to configure that protocol only. Rest of the thing, the router itself will take care. What it will take care, how the packet should travel across the topology, the complete topology. These type of things router will take care.
Okay.
Fine.
Fine.
Anything else?
Thank you very much, sir.
Welcome.
No, thank you very much. Thank you.
Thank you. Have a
Welcome.
nice day. Bye. Bye.